Okay, so can you please tell me about yourself?
Yeah, hi. I have around 3.8 years of experience in software development, primarily working with Java, Spring Boot, microservices, Kafka, SQL, Hibernate, and cloud technologies. And throughout my career, I have been involved in designing, developing, and maintaining the enterprise level backend applications. So basically, they handle the high volume and traffics and transactions. And I have also worked extensively on the Java 8 and 17 as well. And recently, I have started exploring Java 21 features as well. So I have also from the Spring Boot side, I have worked on the 3.x version and also Spring Data JPA, Spring Security, and all that also I have worked on. And in my current role, I am involved in end-to-end backend development, and my responsibilities include like designing APIs, implementing business logic and database design, and integrating the third-party services. And apart from that, I have also been involved in the fixing the production issues and deploying the applications through the CI/CD pipelines. And I also collaborate closely with the front-end developers, QA teams, DevOps engineers, business analysts, and all throughout the life cycle of the project development. So yeah, so this is what is all about. I mean myself. Yeah.
Okay, so can you tell me in brief about your current project?
Yeah, so currently I'm working on a cloud-based enterprise application and that is developed using the Java, Spring Boot, and microservices architecture. And the application consists of multiple independent microservices responsibilities for different business capabilities. For example, we have user management, order processing, then payments, notification, reporting, authentication. So all these different microservices are there, and each service has its own database and exposing REST APIs for communication. And we use Kafka for asynchronous communication between the services. Wherever like event-driven processing is required, and for persistence we are using Spring Data JPA and PostgreSQL. Okay, and also we are using for cache we are using Redis to improve the performance, and authentication and authorization are handled using the JWT tokens and Spring Security. So yeah, so this is what is all about my project. And also this application monitoring is done using the Spring Boot actuator, and we are also using Prometheus and Grafana. So yeah, so this is what is all about my current project.
Okay, good. So, apart from that, can you explain the architecture of your project?
Yeah, so our application basically follows the microservices architecture, as I told you. So the client basically sends the request to API gateway, and then API gateway routes the request to the appropriate microservices, and each microservices owns its own database and communicates with other services using the either REST APIs or Kafka events. Okay. And then authentication is centralized using the Spring Security and JWT, and then configuration is managed centrally using the Spring Cloud config. Okay, and then we have like service discovery, so that is handled using the Eureka in our project, and resilience 4J is being used for the circuit breaker and retry mechanism. Okay, and also I told you like Redis is used for the caching, and applications are deployed as Docker container inside the Kubernetes cluster. So yeah, so this is what is architecture about my project, and also the logs are centralized using the ELK stack. Okay, and monitoring is done using the Prometheus and Grafana. So yeah.
So, can you tell me few points? So, why did you choose the microservices instead of monolith project?
Yeah, so microservices they provide several advantages because we can deploy independently, and also independently scaling can be done for any specific microservices. Suppose we want to scale, so that we don't have to scale the whole application itself. And also it is better for the fault isolation, and for faster development also can be done, like each microservices can be assigned to different team members, and they can develop their own microservices in their own way separately. And also the code base will be smaller, So it will be easy to track and understand and analyze. And technology flexibility is there, so we can use any technology. Some of the applications we are using Java, some of them we are also using .NET and Python as well. So that also can be done, and also it is easy to maintain. So maintenance is easy. So yeah, so these are the reasons why we can go for the microservices whenever it is a big application.
Okay, so can you explain the complete request flow in your application?
Yeah, so like first step is like client sends the request, then it first reaches to API gateway, then the API gateway validates the authentication tokens and routes the request to the appropriate microservices. And the microservices validates the request and executes the business logic and interacts with the code base if required, and then returns the response. And if another service is needed, then synchronous communication happens through the REST APIs, while the asynchronous operations like notifications or audit logging, they are handled using Kafka. So this is what is the whole code flow. Yeah.
Okay, so which Java versions you have worked on?
Yeah, so I have mainly worked on Java 8 and 17, and recently I have been learning like Java 21 and exploring its new features.
Okay, so can you just point out the some points of Java 8, 17 and 21 as well?
Yeah, so Java 8 features includes like a Lambda expression is there, stream API optional, functional interfaces, datetime API. So yeah, so all these are there. And then Java 17 we have like records, seal classes, right? And then switch expression, and then better garbage collection. So and also the pattern matching improvements has been done. So these are comes under the Java 17, and in 21, I think like we have like virtual threads have been introduced, and also like string template and I think pattern matching enhancement also have been done in this further. So yeah.
Okay, so in Java 17 records are also there, right? So can you tell me what are records in Java?
Yeah, so this a record is a special type of class. So it has been introduced in Java 17. So its primarily purpose is to represent immutable data. So instead of writing the constructor getters equals and hash code and to string, so Java generates them automatically. So that's the purpose of it. So for example, like suppose we say public record employee and some method, then that method will automatically create the constructor getters equals hash code to string. So this will be automatically generated. We don't have to manually write and do that. So basically, they are very much ideal for DTOs or any kind of API response we are preparing or request objects we are doing. So in that case, we can use this.
Okay, so can a record extend another class?
No, record cannot extend another class because I think they already extend the record class internally. So we cannot do that. Yeah. However, we can they can implement interfaces, but yeah, they cannot extend the another class.
And how about sealed classes?
Yeah, so sealed classes restrict which classes are allowed to inherit from them. So we can restrict that. So for example, we can just say public sealed class vehicle and then permits car and bike. Okay, car comma bike. So in this case, only car and bike can extend the vehicle. No other class can extend that. So basically, it provides the better control over inheritance and also it improves the security.
And can you explain the switch expression?
Yeah, sure. So, like earlier, switch statements required break statements and were more like kind of verbose kind of. So, Java introduced switch expression using the arrow syntax. Okay. So now we can like just say switch then case. Let's say case Monday. If we are saying we have multiple cases, right? Then we can just say arrow and then we can say like whatever we want to print. So that we can say. So yeah, so that is how we can do that.
Okay, so can you explain the Java collections framework?
Yeah, Java Collections Framework provides basically the set of interfaces and class, and that is used for sorting and manipulating the group of we can say objects efficiently. So, like in Collections Framework, the main interfaces are like, for example, we have list, set, queue, map. Okay, and also like it has implementations like array list, then linked list, hash set, tree set, hash map, linked hash map, tree map. So basically each implementation is optimized for different use cases, so that depends on the insertion, deletion, or like uniqueness. So yeah.
Okay, so can you tell me the difference between list, set, and map? Just points.
Yeah, so list basically allows the duplicates and maintains the insertion order, and indexed collection will be there. Okay, and then set will have no duplicates, and also like hash set like does not maintain order, and again it has again tree set is also there, so that maintains the sorted order. So they are all the part of set, but yeah, the main concept of set is that there will be no duplicate values. Okay, and then we have map. So map like that stores the data as key value pair, so that's the main difference actually. So each key in this case must be unique while values can be duplicated. So that's the concept of this like list, set, and map.
Okay, so what is the difference between array list and linked list?
Yeah, both array list and linked list implement the list interface, but they use different internal data structures. So array list is backed by the dynamic array, whereas the linked list is implemented using the doubly linked list. Okay. So array list provides the fast random access because like elements are stored in like contiguous memory location. So accessing an element by index is like O of order of 1. However, like inserting or deleting the elements in the middle that requires the shifting elements. So that makes it like O of n. Okay, and linked list on the other hand, like that allows the faster insertion and deletion because it only updates the node references. However, random access is slower since it must traverse the list, so that is why the like it takes O of n. Yeah, so that's the main difference. So we can like choose array list whenever the read operations are more frequent, and linked list we can choose when a frequent insertion or deletion occurs in the middle of the collection. So we can use this. Yeah.
Okay, and which one consumes more memory?
I think linked list consumes more memory because every node stores the actual data along with the references to both like previous and next nodes. So I think that is why it consumes more memory. And array list only stores the object references inside an array. So that is why it will be less. That is what I think.
Okay, so can you tell me how does hash map works internally?
Yeah, hash map stores data as a key value pairs. So when we insert a key value pair, then like it follows some steps. Like for example, first of all, the hash code method is called on the key. Okay, and then Java calculates the bucket index using the hash value. Okay, and then if the bucket is empty, then a new node is created, and if another key already exists in the same bucket, in that case hash map checks equals method, and if equals returns true, then the existing value is replaced. Okay, and otherwise like a new node is added in the bucket. So that's the whole steps how key value pairs are added. So actually, from Java 8 onwards, if the bucket contains more than 8 entries and the table size is at least 64, then the linked list is converted into red black tree. That basically improves the lookup performance. So yeah.
So what is this hash collision?
Yeah, so hash collision occurs when two different keys generate the same hash bucket. So for example, let's say we have key A and key B, okay, and both are in bucket 5. Okay, so both keys point to the same bucket. So hash map then uses equals method to determine whether the keys are actually the same. And if key like equals method returns false, then both entries are stored in the same bucket. So yeah, so basically before Java 8, like this was handled using the linked list, but from Java 8 onwards, like when the numbers of nodes exceeds the threshold, then the linked list like is converted into the red black tree in this case also.
And what is the difference between hash map and concurrent hash map?
Yeah, so hash map is not thread safe, and if multiple threads modify it simultaneously, then it can like produce inconsistent results. And concurrent hash map is designed for the concurrent environments. So instead of locking the entire map, it uses the finer grained synchronization and modern concurrency techniques to allow like multiple threads to read and write safely with better performance. So whenever multiple threads access a shared map, then we can prefer the concurrent hash map.
Okay. So can concurrent hash map store null keys?
No. So unlike hash map, concurrent hash map does not allow null keys or null values. Yeah, so this basically avoids the ambiguity in concurrent operations.
Okay, so what is the difference between comparable and comparator? Just in very short.
Yeah, so comparable basically defines the natural ordering of the objects, and it contains the compare to method. So for example, let's say employee object sorted by employee ID, then comparator defines the custom sorting and it contains the compare method. So using the comparator, we can sort it by like any of the property, not only employee ID. So we can use either name, salary, age, department, whatever. So based on any other property, we can sort it. However, in case of comparable, we have to use any one like property and then we can sort it.
Okay. And what is optional in Java 8?
So yeah, so optional was introduced to reduce the null pointer exception. So instead of returning null, methods can return an optional object instead now. Okay, so we can just say, like, for example, let's say from the repository, if you're trying to, like, let's say repository dot find by id we are saying, but that we can now aggregate to the optional. So we can just say optional of user and that object can be holded there. Okay, and that basically forces the developers to handle the absence of the value explicitly. After that, we can further it provides the many methods like each present, if present, or else, map, filter. So many methods it provides. So yeah, so that's what is the optional.
Okay. And can we use optional in entity classes?
In entity classes, we can use, but it is, I think it is discouraged. So because like it complicates the serialization, persistence, and framework integration. So yeah, so optional is mainly intended for the like method return types, not inside the entity class.
Okay. So can you tell me what are intermediate and terminal operations?
Yeah, so Java 8 provides many intermediate and terminal operations. So for example, we have intermediate operations like filter, map, sorted, distinct, limit, skip. So these are the intermediate operations. So these operations are lazy and do not execute immediately. And terminal operations are like trigger the execution of the pipeline. So that is what the terminal operation. So for example, we have like collect, count is there, for each is there, reduce, find first. So they all are the terminal operation.
Okay. And what is the difference between map and flat map?
Yeah, the map operation transforms each element into another element. So that results to like one output element for each input element. Okay. And the flat map operations is used when like each element itself contains the multiple values such as like list of list. Okay, so it flattens the nested structure into the single stream. So for example, suppose if we have like list and again the nested list of a string, so using flat map we can produce only like a stream of string instead of like a stream of like list of a string. So yeah, so that's the difference between these two.
Okay. And what is multi-threading?
Yeah, so multi-threading is the ability of a program to like execute the multiple threads concurrently within the same process. Okay, so that's the multi-threading. And in thread is a very important component of that. So thread is the smallest unit of execution and multiple threads share the same heap memory while having their own stack memory. Okay, so the primary benefit of multi-threading are like we can use the CPU better way, and we can improve the application like responsiveness, and also like throughput will be higher, and also parallel execution we can be done. So that's what is the multi-threading.
And what is the difference between process and thread?
Yeah, so a process is an independent running application with its own memory space, and a thread is a lightweight unit of the execution inside a process. So process do not share memory, whereas the threads within the same process share the heap memory but maintain the separate stack. So that's what is the difference between these two.
Okay. And how do you create a thread in Java?
Yeah, so now there are multiple ways basically. So one way is like extending the thread class and then implementing the runnable interface. That is the like traditional way of doing that. And then we also have the implementing the callable interface. That is how also we can do. And then the most recommended way is like using the executor service. So through that we can also generate the threads. And also we can use virtual threads also in Java 21. We have that way also. So yeah, so in modern application, we generally avoid manually creating threads and instead we use thread pools managed by the executor service or like Spring's at the rate of async. So we can use any of these.
Okay, so why is executor service better than creating new thread?
Yeah, creating a new thread for every request is expensive because like thread creation consumes CPU and memory. But executor service reuses the existing thread and reducing the like overhead and improving the scalability. So that is why the executor service like is more preferred.
Okay, and what is synchronization?
Yeah, so synchronization ensures that only one thread accesses a thread resource at a time and it prevents race condition and data inconsistency. So Java provides synchronization using we have a synchronized keyword is there, then we have locks and atomic classes are also there. So we can use any of these to perform the synchronization.
Okay, and what is this race condition?
Yeah, so a race condition occurs when multiple threads simultaneously modify shared data and that causes the unpredictable result. Okay, so that's what is the race condition. So for example, let's say if two users transfer money at the same time and the balance update is not synchronized, then the final balance may become like incorrect. So that's what is the meaning of this.
Okay, and what are the atomic classes, you know?
Yeah, so like atomic classes provide lock-free and thread-safe operations. So we have many atomic classes like atomic integer is there, atomic long, and then atomic boolean is there. So like instead of count plus plus we can just say count dot increment and get. Okay, so these classes use like compare and swap internally and avoid the explicit locking and improving the performance. That's what is the atomic classes.
Okay, and can you explain the JVM memory structure in very short way?
Yeah, so JVM memory is divided into several areas. Like we have heap, stack, then meta space, then program counter register, and then native method stack. Okay, so heap stores the objects and is shared among the threads, and a stack stores the method calls and local variables, and each thread has its own stack. Okay, and meta space stores the class metadata and the program counter keeps the track of the current instruction being executed. So that's what is the program counter. And then we have like the last the native method stack that is used for the native method execution like non-java operation. So yeah, so that's what is the difference.
Okay, and can you explain heap memory?
Yeah, so heap memory is where like Java objects are allocated. So it is divided into like two parts. One is the young generation, one is the old generation. Okay. So young generation contents again, it has hidden space, then like survivor space like S0 and survivor space S1 like that. So new objects are first created into hidden space and objects that survived multiple garbage collection cycles, then they are promoted to the old generation. So that is what is the whole structure of the heap memory.
Okay, and what is memory leak in Java?
Yeah, memory leak occurs when objects that are like no longer needed that remain reachable through the references, then they prevent the garbage collection. So that's what is a memory leak. So it can happen using like sometimes static collections holding the objects. Then also it can happen or like any kind of unclosed resources are there, or let's say large caches without like eviction is there, so we are not deleting that, or thread local values are not cleaned up, so then also it can happen.
Okay, okay, fine. So when do we get out of memory error?
Yeah, so out of memory error occurs when the JVM cannot allocate additional memory because the available heap or another memory areas has been exhausted. So sometimes it can be because of Java heap space or meta space or garbage collector overhead limit exceeded. Okay, so these can be the reasons for this out of memory error.
Okay, can you explain the Spring Boot auto configuration?
Yeah, so auto configuration like is one of the core features of Spring Boot. So when the application starts, then Spring Boot examines the dependencies available in the class path and automatically configures the required bins. So for example, let's say we have Spring Boot starter data JPA. So that is present. Then Spring Boot will automatically create like entity manager, transaction manager, data sources, JPA repositories. So all that can be done automatically. And again, similarly, let's say if Spring MVC is present, then it automatically configures like dispatcher, server, Jackson, like object map, REST infrastructure. So all that is automatically configured. We don't have to configure these things, and we have to only focus on the business logic. So yeah.
Okay, so that's fine, but how does Spring Boot knows like what to configure?
Yeah, so for that we there are various annotations it looks for. So Spring Boot basically uses let's say for example at the rate of enable auto configuration anywhere it has been written, then it will pick up those. Or let's say we have auto configuration dot imports. So these kinds of statements also it can check, and also like conditional annotations such as like at the rate of conditional on class, conditional on bean, conditional on missing bean. So it also checks for these annotations. So yeah, so these conditions basically determine like which configuration should be applied. So yeah.
Okay, and can these auto configuration be overridden?
Yeah, this can be overridden, yes. So we can override auto configuration. Like for example, we can define our own bin with the same type and exclude the specific auto configurations. So like just we can say add that to Spring Boot application and exclude equal to we can give that exclusion configuration class name. Okay, and we can use also properties in application properties. So there also we can use. So these are the various ways like how we can auto configure. I mean override the auto configurations.
Okay, and can you explain the dependency injection?
Yeah, so dependency injection is a design pattern where Spring creates and injects required objects instead of like developers creating them manually. Like earlier we used to write, let's say any user service is there. So we use at a user service, then its service object equal to new user service. That is how we used to inject. But since like Spring automatically injects this object, so now instead of that, like we can just say at the rate of service, and then public class, let's say order service is there, and then we can use it further. So that basically makes it like loose coupling, and it is like better testing, and also like it is easier to maintain also. So that is what is a dependency injection.
So, which dependency injection do you prefer?
Yeah, we prefer the constructor injection most. So like basically dependencies become mandatory. So that is why we use constructor injection, and the object is immutable after creation, and also it improves the unit testing, and it avoids any kind of null pointer exception like due to missing dependencies. So that is why constructor injection is more preferred.
Okay, so can you explain the Spring profiles?
Yeah, Spring Profiles basically allows different configurations for different environments. So, for example, we have multiple environments. For example, we have like dev, test, QA, or production, right? So each profile can have its own configuration files, right? So we can have like something like application minus dev dot properties, application prod dot properties, or anything it can be. So whenever we want to activate any of them, so we can just say spring dot profiles dot active equal to, we can just say dev. So suppose we are doing the development at dev environment, right? And further when we have to give it in the production, we can just say active equal to prod, and we can give it to like I mean deploy to server, production server.
Okay, so how do you handle exceptions in the Spring Boot?
Yeah, so we can use a centralized exception handling with at the rate of REST controller advice. So instead of handling exception in every controller, we can define the global exception handler. So for example, we can just say at the rate of REST controller advice, and then we can mention the class name, and again further inside that whatever the method names will be there. On top of that, we can just give at the rate of exception handler. Okay, and whatever the custom exception we want to mention the class, we can mention that like user not found exception or whatever. Okay, so that basically provides the consistent error responses and cleaner controllers, and also better maintainability. So that's how we can handle the exceptions in Spring Boot.
Okay, And how can you validate the incoming request in Spring Boot?
Yeah, so Spring Boot provides like bean validation using the we have Jakarta validation. So we annotate like DTO files using like we can use add date of not blank, add date of email, add date of size, right? So these are the various annotations we can use, and then we can also use after that add date of valid. Okay, so that we can use in the controller method. So yeah, so that is how we can validate the incoming request. Yeah.
Okay, so can you explain the JWT authentication in just few steps?
Yeah, so JWT is like JSON Web Token. So that is the compact stateless token. So that is used for authentication. So the flow will be like user logs in with credentials, then the server validates them, and then a signed JWT is generated. Okay, and the client then stores the token, and every subsequent request includes the token in the authorization header. Okay, and then the server validates the signature and extracts the user detail without querying the database for each request. So that is how the whole flow is. Okay, and this JWT basically contains the header, payload, and signature. So it has basically three parts. So that is how the whole flow goes for the JWT.
Okay, and what are filters and interceptors?
Yeah, so basically both are used to process request before they reach the controller, but they operate at different levels. So filters are part of the servlet container and execute before the request enters Spring MVC, and they are commonly used for logging and course and like security related pre-processing. Okay, and interceptors are part of Spring MVC and execute around controller methods, and they are useful for authentication checks, auditing, and request timing, and adding common model attributes. So that's what is the interceptors.
Okay, so when can you choose a filter over interceptor?
Yeah, so we can use filter for like concern that should apply to all incoming requests regardless of Spring MVC, such as like request logging or CORS, so cross origin. And we can use interceptor when the logic is specified in Spring MVC, such as like validating a user before executing a controller or like measuring controller execution time. So in these kind of scenarios, we can use interceptor.
Okay, fine. So can you explain the Kafka architecture?
Yeah, Kafka is a distributed event streaming platform. So the main components of these are like producer, then broker, and topic, partition, consumer, then consumer group, and then offset. So these are the main components. So like a producer publishes the message to the topic, and the broker stores those messages. And then further consumers read messages from the topic, and offset tracks the progress of each consumer. So these are the details of the each components.
So what is consumer group in this?
Yeah, so a consumer group we can say is like a set of consumers working together to process messages from a topic, and each partition is like assigned to only one consumer within the same group, and this basically enables the parallel processing while ensuring that each message is processed only once within that group. So that's what is the consumer group.
Okay, and can two consumers read the same message?
Yeah, that is possible. So if they belong to different consumers group, then within the same group, each partition is consumed by only one consumer. So yeah, so it is possible only when it is in the different consumer groups.
And what is this Kafka partition?
Yeah, so Kafka partition basically allows Kafka to distribute data across multiple brokers and consumers. So it has many benefits like scalability, then parallel processing also can be done, fault tolerance, and high throughput also can be generated. So that's what is the benefits of it. So like messages with the same key are written to the same partition, and that basically preserve their order. So that's what is a Kafka partition.
Okay, and how do you handle duplicate Kafka messages?
Yeah, so duplicate messages can occur because like Kafka typically provides at least once delivery. So to handle duplicates, I we can make the consumer idempotent, so that we can do like using the unique business IDs we can give, and we can also like we can check whether a message has already been processed or not, or also we can maintain the processed message records, and also we can like leverage the database unique constants wherever appropriate. So all these points like these ensures that like processing the same message multiple times does not produce the incorrect results.
Okay, and what is pod in Kubernetes? Do you know?
Yeah, pod like is the smallest deployable unit in Kubernetes, we can say. So it can contain one or more tightly coupled containers that share networking and storage. So that what is the pod.
Okay, and what is blue-green deployment?
Yeah, so blue-green deployment is a deployment strategy that minimizes the downtime, and the current production version runs in the blue environment and the new version is deployed to the green environment. Okay, and after validation, like traffic is switched from the blue to green. So that is what is the blue-green deployment. So if any issue occurs, then traffic can quickly be redirected back to the blue one. So this basically provides the safe release and rapid rollback capability. So that's what is the blue green deployment.
Okay, and do you know what is canary deployment?
Canary deployment, yeah, so the new version is released to a small percentage of users first, and if it performs well, then the traffic is gradually increased until like all users are on the new version. So I think that's what is the canary deployment.
Okay, so coming to SQL, can you tell me what is an index in SQL?
Yeah, an index in a database object that improves the speed of data retrieval. And without an index, the database performs a full table scan. And with an index, it directly locates the required rows. So that's the main difference. So basically, index improves the select performance, but increase the cost of insert, update, and delete operations because the index must also be maintained. So that's what is the index.
Okay, and can you tell me what is JPA?
Yeah, so the JPA is Java Persistence API, and that is a specification for the object relation mapping. And Hibernate is the like most popular implementation of this JPA. And JPA allows us to work with the Java objects instead of writing the repetitive SQL. So that's what is the JPA. So yeah.
And what is the difference between JPA and Hibernate?
Yeah, so the JPA is a specification that defines the standard persistence API. So Hibernate is an implementation of that specification. So in practice, we write JPA based code while like Hibernate performs the actual ORM operations. So all these object relation mappings are done by the Hibernate.
Okay, and what is the meaning of cascading? So cascade types we have, right?
Yeah, so basically cascade types define how operations on a parent entity affect its child entities. Okay, so like we have various cascade types. For example, we have persist, merge, then detach, all. So these are all like various cascade types. For example, let's say we have cascade type persist. Okay, so that ensures that when a parent entity is saved, then its child entities are also like saved automatically. So that's what is the like meaning of this cascading.
Okay, can you explain the Maven life cycle? Just tell me the life cycle names.
Yeah, so Maven follows the build life cycle. Like it has various steps. For example, we it has validate. Okay, then it has like compile, test, package, then verify, install, deploy. So these are the life cycle stages are there. So each phase basically performs a specific task, and executing a later phase automatically runs all like preceding phases. Okay, so yeah.